Animation of Scalable Vector Graphics, an open XML-based standard vector graphics format, is possible through various means. Scripting ECMAScript is a primary means of creating animations and interactive user interfaces within SVG. Styling. Since 2008, the development of CSS animations as a feature in WebKit has made possible stylesheet-driven implicit animation of SVG files from within the document object model. SMIL, Synchronized Multimedia Integration Language, a recommended means of animating SVG-based hypermedia, is currently supported by the Safari, Opera, Mozilla Firefox, Google Chrome and Maya web browsers, as will any browser that aims to pass the ACID 3 web standards test, as this requires SMIL support for Test 75 and 76. Libraries have also been written as a shim to give current SVG-enabled browsers SMIL support. This method is also known as SVG plus time. Because SVG supports PNG and JPEG raster images, it can be used to animate such images as an alternative to APNG in multiple image network graphics. History. SVG animation elements were developed in collaboration with the W3C Synchronized Multimedia Working Group, developers of the Synchronized Multimedia Integration Language. The SYMM Working Group, in collaboration with the SVG Working Group, has authored the SMIL animation specification, which represents a general-purpose XML animation feature set. SVG incorporates the animation features defined in the SMIL animation specification and provides some SVG-specific extensions. SVG in HTML. The SVG can be embedded into HTML with the tag element. By using the SRC attributes in the image tag, it is possible to refer to an SVG file. This only works sometimes and not compatible for old browsers. Solution for browser compatibility. The most common solution is to use the element, with the data attribute referencing the SVG file. When a browser does not support this, it falls back to the content inside the. This could be a rasterized fallback. This method gives a vector image with an alternative rasterized image for browsers that don't unregistered trademark T support SVG. The downside is that both formats need to be managed, and some browsers will download both the SVG and the rasterized version, becoming a performance problem. Solution for performance problem. Using inline SVG combined with an SVG element solve the performance problem. This is an SVG of pointing to the vector SVG representation and a SRC attribute to the rasterized version. Older browsers will rewrite the element as and use the rasterized SRC attribute, but modern browsers will show the vector SVG. Which method is best depends on which browser the developer chooses to support, and severity of performance issues. Libraries to get started. There are several libraries for starting out with SVG animation. They also abstract all browser compatibility issues. GSAP, RAFL, Snap SVG, SVG.js, Velocity.js. Examples. The following code snippets demonstrate 3 techniques to create animated SVG on compatible browsers. The relevant parts are in bold green. SVG animation using SMIL. SVG animation using SMIL. SVG animation using CSS. SVG animation using CSS. At keyframes ROT-KF from transform, rotate, 0 deg. To transform, rotate, 360 deg. At Moz keyframes ROT-KF from Moz transform, rotate, 0 deg. To Moz transform, rotate, 360 deg. At WeakKit keyframes ROT-KF from WeakKit transform, rotate, 0 deg. To WeakKit transform, rotate, 360 deg. ROT animation, ROT-KF1's linear infinite. Moz animation, ROT-KF1's linear infinite. WeakKit animation, ROT-KF1's linear infinite. Note: the Moz and WeakKit styles are pre-CSS3 browser-specific styles. SVG animation using ECMAScript. SVG animation using ECMAScript. Function rotate, EVT, var object equals evt target owner document get element by id, rot. Set interval, function, var now equals new date. Var milliseconds equals now get time percent 1000. Var degrees equals millisecond 0.36. 360 degrees in 1000 miss, object set attribute, transform, rotate, plus degrees plus closing round bracket. 20. Authoring tools. Conversion tools. There are some tools like Google Swiffy which can convert SWF, including Flash animations to SVG animations. Swiffy uses JavaScript to animate the SVGs it produces, which are not stored as such on disk, but serialized as JSON. SMIL attributes to identify the target attribute. The following are the animation attribute which identify the target attribute for the given target element whose value changes over time. Attribute name equals, specifies the name of the target attribute. An XML-NS prefix may be used to indicate the XML namespace for the attribute. The prefix will be interpreted in the scope of the current animation element. Attribute type equals CSS XML auto, specifies the namespace in which the target attribute and its associated values are defined. CSS, this specifies that the value of a attribute name unregistered trademark is the name of a CSS property defined as animatable in this specification. XML, this specifies that the value of a attribute name unregistered trademark is the name of an XML attribute defined in the default XML namespace for the target element. The attribute must be defined as animatable in this specification. Auto, the default value is auto. The implementation should match the attribute name unregistered trademark to an attribute for the target element. The implementation must first search through the list of CSS properties for a matching property name, and if none is found, search the default XML namespace for the element. Note: MediaWiki automatically generates static, non-animated thumbnails of SVG images. Viewing the actual SVG image from each respective description page will show its animation in a compatible browser. See also, Flash animation, CSS animations, D3.js. References. External links, SVG 1.1 specification animation, SVG animation and other SVG tutorials, SMIL animations embedded in SVG chapter from SVG Primer.